Okay, so we're going to start. Thank you. So, great, thanks. Okay, so we're at time, folks. Welcome to the late meeting at IETF 119. And in late breaking news, we've had some RFC numbers. So ad hoc is now 95.28. So well done, everybody. Yeah, it happened very recently, so it didn't make it into the chair slides just yet. And the first image of fireworks I found was Sydney, not Brisbane. But yeah, you do your best. It's close. I'm actually going on holidays after at 5 o'clock today, as my holidays begin, and I will be heading to Sydney eventually. So, okay. So with that, yeah. Well, I won't be staying somewhere, but we can chat. Okay. And the chair slides that don't include our RFC numbers include the usual things. So my name is Stephen Farrell. I'm one of the co-chairs. Militia is remote today. So
hello, folks. Yeah, I'm here.
So Militia is on a hotel Wi-Fi or hotspot or some combination of those two. So might disappear at some point, in which case I'll try to do my best.
I'll try not to.
Okay, thanks, Militia. So this is the note well. I guess you've seen this probably if you've been at the IETF meeting all week. You should note it well, or you should have already. And note really well is to behave ourselves and be nice. And this has not been a problem with this group, so that's fine. For IETF meeting tips in person, please make sure you sign in to the data tracker. There's a QR code on the screen there you can use, or use the on-site tool. For remote participants, please keep your audio and video turned off unless you're presenting or in the queue. And if you want to get in the queue to ask questions or make comments, then please do so at the appropriate time. And there's a button you can raise your hand in the bottom middle of the screen that allows that to happen, and we can run queuing. And to be nice to the remote people, if people present here do the same, that's good. So we have Christian and Marco have agreed to take notes with help from John, who's present. Christian and Marco are remote. So we have note takers. We have an agenda, or some links, including the agenda, the Meet Echo, and minutes link. Status is out of date because we have 2 RFCs issued now. So ad hoc and traces are now RFCs. We had this candidate for working group adoption draft implementation considerations, what Marco has written. There was no feedback received. So if some people could just send a mail to the list saying, yes, adopt this, that would be good for the record, I think. I don't think there was any issues with adopting it. People seem to like the work. But it would be helpful for the record if some people can say, yes, adopt it, rather than silence. So please you can take a minute to do that now even. Or if you want to speak against adoption, then please definitely do that. So our agenda for today is we're in the middle of the administrivia. Giovanni will talk about Lake AuthZ. Marco has the app profiles. Yuxan has the Lake RA. John has a couple of slides on ad hoc with PSK authentication. Excuse me. And we have an if time permits presentation, kind of almost last minute on let me find the words. IoT Disco. Johan is going to present as some not working group topic, but a related kind of thing that people may find of interest, if time permits. So anybody want to bash the agenda?
Yes, please. For my presentation, after I finish the slides, I think maybe I go between 10 and 15 minutes, probably. I think maybe there'll be some discussion. So
Giovanni, can you go a little bit closer to the microphone? It's a little hard to hear in the room.
Okay, sorry. Now it's better?
Yep.
Okay, so for my presentation, maybe I will need an extra 5 minutes, if that is okay.
I think we can afford that.
Nice, thank you. And
Okay, and Marco?
Yeah, hi. I have a similar request if time allows, considering the slot is 90 minutes in total. 15 minutes for my presentation would be easier to handle.
Everybody wants more time today. That's okay. Yeah. Don't forget, I have to go on
yes,
holidays at 5 o'clock though. So, but yeah, I think that should be all
Thanks.
fine.
Thank you.
and I'm sorry because I am again here asking for time twice. I'm sorry for that. But
No
I have
worries.
a demo. It's a short video of the implementation that could go in the any other business if that makes sense.
Well, given it's kind of last minute, if we get there and have time, we'll get there and have time. So let's see how that goes.
Of course. Thank you very much.
Okay. Okay. Any other agenda bashing? Okay. And with that, I think Giovanni. So let me. So Giovanni, do you want me to pass control of the slides to you?
Yes, I think that could work.
Okay, so you should be able to see the forward and backward icons now. Okay, off we go.
Okay, great. Thank you. And good morning, good afternoon. I don't know, everybody. This is Giovanni. I'm going to talk about lightweight authorization using ad hoc. And I will do firstly a very quick recap of the protocol. I'll show also quickly some updates on the implementation. Then I'll spend more time on the updates of the draft and some open issues and next steps. So recap, lightweight authorization using ad hoc. Maybe I will be referring to this as just alts or even zero touch network join or enrollment. So that's the way we commonly refer to the protocol. So we have three entities, a device, a domain authenticator, sometimes we also call it a gateway, and an enrollment server, U, V, and W. The device wants to enroll a domain, and we use ad hoc for that. And on top of that, we add external authorization data so that the device can request and obtain a voucher if it's authorized by the enrollment server. So that's the main flow of the protocol. As for a quick update on the implementation, basically we have the important thing here is that we have the lakeouts 00, it's fully implemented now, and we have a working demo in real hardware. So we are trying to validate the draft as we develop it. Okay, now first update is that the voucher can now carry this, can carry some data, because previously the voucher was defined as being just a message authentication code. And after some discussion, we decided that it might be useful to be able to carry some encrypted data between U and W. So now the voucher is the ciphertext of a COSA encrypt 0 object. And just a note that the ciphertext will contain a MAC. So even if the plaintext is empty, the MAC will be there, so it will be equivalent to the previous construction. So what kind of data? So let's discuss about opaque info. So we had a problem where we identified that in certain situations, U and W may want to exchange information. For example, from U to W, maybe U wants to send some context around it, for example, the gateways that are nearby. From W to U, there are two scenarios. For example, if it works, if the voucher request works, then maybe we want to inform U whether V is an owner with admin access or simply an access provider, connectivity provider. Or maybe if an error happened, maybe we want to send some extra information about the error. And our proposed solution, which is on version 01 of the draft, is to add opaque info field that is encrypted between U and W. And here is an example of how to use it in the request, in the case number 1 that appears in my slide, which is 1 U to W, sorry. And in this case, we are adding opaque info to the struct that is now called enqueue info. So this allows, for example, a device sending some context to the W entity. We also added a mechanism for error handling. So we defined a new ad hoc error called access denied, and we define it as a generic error for ad hoc first. So we are defining the error code. We defined a specific error content, and that can be a reject type, where we can tag it, and optionally can have a reject info. And inside the reject info, we can have some opaque information that the idea is to use it as actionable information about the error, so that when you receives the error, it can do something about it. And note that the addition of the opaque info here is something specific to Lake Alts. It's not for the general error case of the ad hoc error access denied, which we are defining in this draft, but we think it might be useful, could be useful in other scenarios. And we will have an example of what could be in this opaque info in the next slide. So here I will talk about enrollment hints. So one problem that we identified was the following. If we look at the picture, we have device U1 and then 3 gateways. So if the device tries to join via gateway V1 and then it fails, and tries via V2, it fails again. And then, Malisha, you want to speak?
So we have Joran in the queue. I think Joran wanted to ask a question.
Okay.
I can take it later. I can wait. It's okay. I take it later.
Okay.
Please continue.
Yeah, go ahead, Giovanni.
Okay. So if only in the end when V3 it works, so it means that the call to V2 it could have been spared if U1 could have a hint about that it should reach V3 after getting the first error from V1. So the idea is to enable this kind of hints in the protocols. So the first one is what we defined as a U hint, with which enables U1, the device, to tell the server which gateways it has scanned, it has discovered. So, and then the next hint is V hints, where W may tell the device which gateways it should use, that it should be authorized if it should use. So these hints are optional, and the idea is to speed up enrollment when there are many Vs available. Yes, Joran?
Yeah, no, maybe now is a good time. So I had a question about this use case here. What is it? So is it actually why does it matter which gateway? Is there a load balancing here? What is the use case for why does it matter from which gateway you choose?
Okay, so for example, I will bring a use case here. If you have a device inside a building, and then in this building you have multiple access points from multiple stakeholders, and you want your device to join via your access point, but the radios overlap. So you want to define your policies in W such that the device is using a specific kind of gateway.
Okay, yeah, that makes sense. Thanks. I had another question in the previous slide. So yeah, so it's basically the error code. We didn't define any error code of this kind in ad hoc, because ad hoc is extensible, and we can add error codes as we go. I just wonder if this is the idea here is that we are using the error code for something specific because it's actionable. Maybe that's a point worth highlighting here, that the error code. So the current error codes are are only actionable error codes, and what makes this actionable is actually that you have this relationship between U and W, so you can actually pass trustworthy information back to the client. So if you have an access error codes are not messages are not protected in general. But in this case, you can carry content which actually can be verified, and then you can act on things like access denied in an automated way. That was just a comment. And I actually
Yes,
have a third
correct.
question, if I may, on the next slide, and that I think was a
course.
question by Stephen or someone saying that what is the privacy aspects of gathering information about gateways now?
That was indeed my question.
So I think that's a good question. I just wondered, is this a security consideration? Is this how do we handle that? I mean, you are entitled to do some collection of information, and it somehow depends on what you do with that information, I suppose. Or does anyone else anything to add on that?
So I guess Michael's in the queue. Let me just state my question as well, since I jumped in the queue for it. Typically, if your device is connecting to something and we're creating the capability to send a list of nearby identifiers, that is privacy sensitive. So I think we need an answer to that question. Michael?
Wish it was taller. So you is listening to the radio to get this list of V1, V2, V3. And I agree that its privacy information or sensitive, should W decide to make it public or otherwise do interesting things that would be interesting to it with that list. You, on the other hand, can go and try and onboard via V1, V2, or V3, each of which is going to effectively contact W, revealing V1, V2, and V3. That within the normal course of operation. And any device could do that. Or any interloper in that environment could collect that information, is what I'm trying to say. So as long as the entities on the path cannot view it, so random hobos on the internet can't see that list, then I don't think it's as interesting or as sensitive as there. That's what I'm saying. I agree with you that there's information in there that's sensitive, but I'm saying the question is, who are we disclosing it to and how long? So I think it would be bad if, yes, W went and put it on a web page, okay, or did other things. And we have evidence that this has happened with, smartphones and access points and that kind of stuff. I think this is less of an issue until at some point. So I don't know how the V hints is going to work. That's I think that may be actually kind of more complicated and more potentially exposing because I don't know if it will work well.
So, I think for now it's sufficient to note that there's a privacy question that needs an answer.
Question, yeah,
and it needs an answer.
Right, and I think that open questions. What exactly are we communicating? And for that, I think that's perhaps we can reduce that information to somewhat of enough of a subset that it doesn't matter. Okay.
Sure. Yeah, no, I mean, we don't need to figure the answer today or
Yeah.
right now, but I think we do know that we will need to have an answer.
The other thing I want to say is that given that the goal of this is to do very little work, and ad hoc is designed to do things very efficiently in a very byte compact and a very crypto efficient way, trying all three may be not a problem, as much of a problem as for other environments. So it might be that we find that this is actually useless, not very useful in the end.
Possible.
Right.
Okay, great, thanks.
Okay, thank you very much. So, okay. And the final open question here is if we proceed with this design, and then what kind of identifier? We have many of them in the IoT world, so this is something to consider. Okay. We also added some examples to the draft. One of them is minimal and demonstrates successful execution. The second one demonstrates an error case when the device selects the error wrong gateway, and also illustrates how the information about the hints about the gateway can be sent as part of the error message. Now I proceed to some open issues. Number 19 is to explain the error in the VRES protocol. So right now, what we defined is the access denied error that goes into the ad hoc interaction, the blue box on the left, and we need to define on the red box in the right. So what happens in this kind of in the interaction between V and W. So this is next steps. We have issue number 21, which is about auths with inverted ad hoc roles. So that means, so normally U is the initiator and V is the responder. And then the question that arose is, should we invert that? And I mean, should it be possible to be inverted? So I just did a quick sketch of how this could look. And the question was about if this something was fundamentally preventing this. I don't think so. I think the main question is how much it is needed. Someone has a use case for this. I'm not sure. And then there are a few issues that I opened because I was thinking if we could make the opaque info less opaque. And what I mean by that is to try to be more concrete. So this is an exploration that I'm doing, if it makes sense or not. So let's focus on number 23 here on the top. So where we have is what I just presented, IDU, and then we added opaque info. And then on the right is the alternative, which is sending just a list of the nearby gateways. So the idea is to be more interoperable by adding this specific field. On the other hand, we don't know if maybe the device wants to send more context, a different kind of contextual information that will help W in make this decision. So how much we want to open, how much we want to be specific here. I think that's a point to discuss. And I will not go into details of 24 and 25 because the logic is similar. I see that there is a question of Joran.
So, yeah, I don't know if we have time for this, but I just wanted to, while reading this, I had some ideas. So I just put them here and see if we have time, we can discuss them.
Okay, great.
I mean, I think probably in the interest of time, let's try and get through this and take it to the list mostly, I guess.
Yeah, of course. And there is also a proposal of how to handle the problem of many types of network IDs here on the right. We can discuss. There are some stale issues that are still open, and my suggested action is to close, but I think we can discuss them in the issue tracker. So as a final wrap up, we have the implementation closely following the draft. I say closely in marks because we implemented version 0.0 and we are just releasing 0.1. We have new ways to share information between U and W. We have a new ad hoc error code, and we have some open issues and a clear path for next steps. That's it. Thank you all.
Thank you. Great. And who's next?
It should be me, Stephen. App profiles.
There we go.
Right. Thank you. So
I'll give you control.
thank you. Yeah, this is an update on this draft on coordinating the discovering, use, and so on of application profiles for ad hoc. And yeah, to recap why we started to do to do this work? Well, EDOC has defined the concept of application profiles as a set of information that peers are supposed to be aware of in advance to ensure that even on top of possible negotiations during the protocol execution, they can complete it successfully. Of course, it leaves it open other side questions on how to enable or to some extent facilitate the discovery, the use, even the definition of EDOC application profiles. And some thoughts in that direction started already last year in a core document that to some limited, very core specific extent was addressed. But on the general topic, it was preferred to move this to the Lake Working Group that ended up even to be tracked in a sentence that I'm quoting here from the charter. Taking that into account, the scope of this document is multidimensional, but it really starts with defining an IANA registry where to register integer identifiers pointing to predefined and registered EDOC application profiles, so identified by an integer profile ID. And then this in turn can be used in different venues to directly point to an application profiles, for example, as a value of a target attribute in a web link, or as value in a parameter of a dedicated structure, such as the EDOC information object defined in an EDOC related ACE transport profile to avoid confusion. And that in turn evolves into abstracting away from any context, application setup, and so on, and defining instead a canonical representation of how an application profile looks like, preferably using a CBORD item. And last but not least, defining one or more well-known application profiles of EDOC, where well-known was really the term used for a while now, with interest to reflect what is most expected to be used and hence eligible for a registration even from the working group in the IETF in that registry this started with. Okay, this is an example of a few things I mentioned before. If you consider, for example, the web link case and a registry existing where some application profiles was registered with identifier 500, you can indicate in a link that a certain EDOC resource at the server is supporting profile 500, whatever it says. And that's, of course, more efficient than what is done in the second example in the previous link to indicate another EDOC resource that works in a different way and where we are spelling out the different information elements of that whatever other profile. And similarly, on the right instead, there's the definition and registration from this document of a parameter for the EDOC information object defined and used in the ACE document that I mentioned before, where in the ACE workflow, this parameter can be used to indicate what EDOC application profile that your peers are expected to use later on. So same semantics and meaning, really just expressed with different means in different venues. Okay, on the canonical description, we try to keep it as simple as possible as a minimalistic CBORD map that has to include, no matter what, really a minimum amount of items, so the integer identifiers, of course, and the methods and the types of authentication credentials intended to be supported by peers using this profile. Some things don't make sense and must not be included. Anything else is optional to include. And we have defined also media types and co-op content format, just in case this representation have to be transported as payload in messages. For example, in case you retrieve these descriptions of these profiles from a repository. Okay, what happened since November? We got unexpectedly good feedback on this particular topic from Brian on the mailing list, and it started as a discussion on considerations for implementations of EDOC, but what he really meant was really something about this. I'm just quoting here the conclusion on the discussion. Well, he's happy that means like this started to be defined, especially as abstracting away from context, application scenario, technology, and so on. So we submitted the current version 1, and other than manual editorial improvements, we took away a lot of content related to some parameters that express information for an ad hoc application profiles, but are actually pertaining to the ad hoc information object of the ACE document. So we moved them there. The only parameter kept here is really appprof that I showed in the previous slide that really has to be kept here as pertaining to the profile ID identifier defined here. We also clarified what is supposed to be or not to be in the canonical representation in CBOR. And we had another pass on what conceptually is expected to be part of a described ad hoc application profile, looking especially to the ad hoc RFC. And we were missing a few things like the possible definition of a maximum message size and transports to use to transport ad hoc messages. With that in mind, we have a number of open points. This has been floating around for a while already. Right now, we are very strict with a black and white approach in defining what of ad hoc is supported by a certain peer. The two really neatly separated approach are either you say piece by piece the different aspects of a certain profile, or instead you go the totally different way with a straight identifier. And this is fine. It's what we have now. We are wondering if it's better to introduce one single hybrid exception where you can basically use the profile identifier, but in addition, you may specify EAD items to be supported on top of course, any already part intrinsically of the profile definition. This is just because I'm worried that otherwise there will be a kind of wild registration of ad hoc application profiles that are very similar with one another, with the only difference that they support possibly overlapping subsets of EID items, and they will be just a waste of registrations. So it's an open point. This is our view, admitting this hybrid exception. If there are no objections, we plan to take that path for the next version, but whatever we do, it has to be consistent with what is done in the same respect in the ACE document. So is there any thought about this particular point? Yaran.
Yeah, so just one thought here. What you said was that EAD items could be included in the profile even if you allow the hybrid version. So that means that I think it's kind of safe. So you could have profiles which are completely defined, including certain EAD items, and if you support that, then then you only use that identified profile ID for that. And then if you want to add things on top of that, those could be specified with web link. Yeah, I think that makes sense. You allow both.
And I don't expect we need to do anything like that for other information elements, really. It's not that I expect a crazy registration of site receipts and so on, but EAD items are different. Christian.
Do EAD items need to be spelled out in Discovery in the first place? I mean, they do have the distinction between being optional and being mandatory. So is that not an extension point that can be used without further negotiation?
EAD labels are only positive. Then you may have them switch to negative only on the wire.
Yes, but my point is a user of ad hoc can, if something is really optional, can put them in there in an optional way, so they don't have to be all agreed on in the first place, but they can be negotiated as the ad hoc exchange is going along. So I'm wondering whether we really need to advertise each and all of them, which would then lead to the explosion that you were mentioning.
So you think it's not necessarily solving a known problem?
Yes.
Yaran?
Yeah, Christian has a point, but I think you could use both. I mean, you could either negotiate them as you like, or you can allow them to be specified, so that they don't exclude each other. I mean, if you want to specify that this is exactly the EAD items I'm using, then you can do that. Or if you want to keep it open and try, if it works, that also works.
What if one implementation wants to make it clear that it supports a specific EAD item, because not all implementations will support all EAD items.
Then you would need to add them explicitly here. But if you allow this trial and error, then you don't need to specify them.
And Giovanni, this is a description of a profile. So it's more about if you decide to adhere to this profile and follow it, well, then your implementation has to follow suit. Otherwise, you are not supporting the profile. Okay, but there is from this to make it a try in both documents. So this one and the ACE document, because they have to be aligned in this respect. And well, if someone screams later on, we can revert. Thanks for the feedback. Okay, as I mentioned quickly before, we noticed we were overlooking some other information that is worth specifying in a profile. On the maximum message size, that should be trivial. It's about unsigned integer. Maybe it's worth to treat this information separately for the different possible ad hoc messages. On the type of endpoint identifiers, the ad hoc RFC gives one possible example, UI64. I suspect this also ends up in integer identifier and possibly in a new dedicated registry of ad hoc endpoint identifier types, unless I'm missing an already existing registry that can be exploited for that. In case, please say. And then on the transports to use for ad hoc, that may actually be not super trivial. Bottom line, it can boil down to integer identifiers pointing to a transport to use. But then we need some thought on one hand for the distinctive specification of the transport to use for a peer acting as initiator or responder, and conflating to a single parameter in case the same applies to both. And this is consistent with ad hoc already mentioning that we don't have to expect the same transport to be used necessarily by both peers, possibly thinking of proxies translating between protocols, deployed in between. And again, I suspect this will end up in a registry for identifiers of ad hoc message transports. And then I wonder if mentioning the actual protocol is enough, or that evolves into more specifying the protocol together with some transport-specific parameters a la transport suite. But maybe it's too early to imagine well, and we can take this step by step. Any thoughts or anything else missing from this list especially? Hernan? Okay, and the last thing is on the well-known profiles. We need to start from something. So I starting from that, imagining something really minimal that you can see on the top row, left and central row, left and central column. Sorry, I thought of two possible minimal profiles that are different only with respect to the cipher seats, and the top left one is basically the setup considering the second trace of 9529. On the totally extreme side, other side of the spectrum, you have the advanced profile that is not really complete, because you may have today already even more cipher seats and credential types to be used, but still it is quite advanced, and I can imagine it as something on a full-fledged ad hoc peer. And then I try to imagine some middle ground in the central and bottom row, starting from the left and center with basic but better than minimal profiles that start admitting two methods already, and consider also CCS and certificates as X509 or C509, but only by reference. And then if you further escalate this, you get to the right on the intermediate improve application profiles that support both type of certificates, both by credential and value. So this is just the first sketch and can go anywhere, but again, I prefer to start it from something. So please provide any feedback about adding something that should really be considered in the mindset of well-known, or about trimming this. But we can take this as a starting point to provide some nailed down examples and encoding in CBOR of these well-known profiles. Thank you. And that was my slide. We'll work especially on these open points for the next version. Comments are welcome.
Great, thanks. So I assume, Marco, more or less the intent is to revise this again, then head towards working group adoption call at some point. Should not do this.
Hopefully, yes.
Okay, cool. Thank you.
Thank you all.
So next up, Xian. So you should have slide controls, Xian.
Yes, thank you. So hi, my name is Yuxuan, and this presentation is about the draft for doing the remote attestation of ad hoc. So to verify and confirm the integrity and trustworthiness of a remote device or system, we need to do the remote attestation. And the process for the remote attestation has 3 roles. The attester, which is currently in an untrusted state and needs to generate the evidence about itself. And the verifier is the entity that can evaluate the evidence and generates the attestation result. The final entity is the relying party, which can consume the attestation result and generates a level of trust and decide what to do with the attester. And the architecture for doing the remote attestation has been defined and standardized by the working group RES. And there are 2 types. One is the background check model, and the other is passport model. So my current focus is on the background check model, which the relying party is responsible to transfer the evidence to the verifier and get the attestation result back from the verifier. And the first version of the draft has just been released. It defines how to do the remote attestation procedure using the EAD fields in ad hoc. So the general overflow is like firstly, the attester sent the attestation proposal to the relying party, which contains all the provided evidence types, and the verifier can select the evidence types that it can support. And the assumption here is that the relying party also has some knowledge about the attester, so it can narrow down the selection to only one evidence type and send it back together as an attestation request to the attester. So for the attester, once it receives the attestation request, it will call for the attestation service and to generate the evidence. So finally, the evidence will pass to the relying party, and then the verifier will generate the evidence, will generate the attestation result based on its appraisal policy and send back to the relying party. And mapping this to ad hoc session, the attester will collocate as the role of initiator, and the relying party will collocate the role as the responder. The verifier is currently out of scope in this specification. The relation between the relying party and the verifier should be a web-based trust, and the session could be like either TLS or ad hoc plus or score, but currently it's out of scope. So back to the ad hoc session, the 3 EAD values has been defined as attestation proposal, attestation request, and the evidence. And a point that I want to discuss here is for the EAD labels. Particularly for the criticality of EAD labels. My initial idea is that EAD1 is not critical because if the initiator sent the attestation proposal and the responder, if it cannot handle or recognize the attestation proposal, the whole ad hoc session could be still be continued. But for EAD2 and EAD3, they should be critical because once the responder sent back the attestation request, it means that the attestation need to be continued. So if the initiator cannot handle or recognize the attestation request, the whole ad hoc section should be aborted. And the same for EAD3. If the initiator has already sent the evidence to the responder, but the responder cannot recognize the evidence, cannot deal with the evidence, then the ad hoc session should also be aborted. So then for the details about the EAD fields, EAD1 contains an array of all the supported evidence types by the attester. And here the evidence type is indicated by content format ID, which is registered for under the co-op content formats registry. And particularly, it should precise the formats of the claims and also profile of the claims. So for example, in the PSA draft, it will indicate precisely that the claims will be in CWT, which is a format of EAT token, and the profile of EAT is for PSA tokens. And for EAD2, it will contains only one integer as the content format ID, which is selected by the relay party and supported by the verifier. And the nonce is generated by the verifier, which is 8 to 64 bytes long, and forwarded by the relay party. And for EAD3, it is a serialized entity attestation token, which contains the attested claim site to describe the state and characteristics of an entity. And in one claim in the EAT called EAT profile will indicate the choices made for the implementation options, as we don't want to carry all of the EAT claims inside the message. And we want that both entities understand what is required for the implementation. So we will use EVT profile to indicate that. And the ET profile have not be in any particular format. It can also define and register one or more new claims if needed. And once the profile consumes the EAT, it will produce the attestation result according to its appraisal policy. So my conclusion is that firstly, the draft defines how to do remote attestation over ad hoc based on REST architecture. And my current focus is on background check model. And this draft defines the 3 EAD atoms in ad hoc. And my next step is firstly to complete the examples in the draft. And there was a question from the last Lake interim meeting about the size estimated for EAD3. So here is an example that generated by IET verifier tool. This example is not guaranteed for implementation. The idea is to show that, for example, a PSA token with 2 software measurements, the final cosine 1 PSA token size is 453 bytes. And also the next step will be like to start the preliminary implementation, and any reviews and comments are welcome and appreciated. Thank you.
Thank you. Yeah, Mohammed.
Yes.
Go ahead, Mohammed.
Hello, do you hear me?
Yes.
Only just if you can be a bit closer to the microphone.
Okay, is it better now?
A little bit, but go ahead.
Okay, so on slide 5, you were mentioning about the roles mapping from the RATS architecture to the ad hoc, exactly. So
Yes.
I'm still a bit confused about, or maybe I missed something. So just to clarify, so what you are saying here is the verifier role is out of scope for your draft. Is it correct?
Yes, like currently, how verifier treats the information is out of scope.
But then, like, how do you do the attestation? Like, the verify role is, I believe, the most important part that's going to do the verification or the appraisal process. So without that, how would you complete the protocol in itself? Like, if you don't have that appraisal policy, if you don't have the verify role, so I don't believe that you are actually doing the attestation completely. So it doesn't make sense to me. So I'm not sure. One other alternative, in my opinion, could be that the verifier is co-located with the responder itself. That's the verifying relying party, as it's called in the RATS architecture. Not really called that way, but that's the understanding behind that kind of intuition, that the relying party is co-located with, or the verifier is co-located with the relying party. So I believe that would make more sense rather than saying that it's out of scope. So I'm not sure whether that was the intention, because
Yeah,
otherwise
okay.
it never makes sense to me. How would the attestation process itself complete without, how would the protocol itself, proceed? So saying a major entity, a core entity out of scope, is not correct, I think.
Okay, I understand your question. So, because firstly, my current purpose of this draft is to define how to transfer the messages in ad hoc to complete a remote attestation. And in ad hoc, there are like two roles, initiator and responder. So I want to currently focus on how to transfer the message in EAD field of ad hoc to do the remote attestation, which means that it's the initiator and the communication of ad hoc session is between the attester and relying party. And because currently I haven't started the implementation. So you're right, if I implemented execute, I need to know that how verifier do everything. But currently I just focus on the transfer of the message.
I mean,
I will think about adding the verifier, like what verifier does in the future, maybe when I start the implementation.
yeah, that's fine. But what I'm saying is that it's not related to the implementation. What I'm trying to say is that it's related to the specification. If it's not specified, I believe the specification itself would be incomplete. That's what I'm trying to say. So without the verifier, how would the proceed? So on the responder side, I mean, how is it going to who is it going to ask to verify that evidence that it will obtain from the following the RATS terminology? That's the evidence, right? So who is going to provide the responder the response, the result for that? I'm completely unsure on that. So how would you even write the specification without going into the implementation? That's a separate thing. So I believe it's a core point inside the specification itself rather than saying it's an implementation detail.
Yeah, yes, I understand your yes. Because right now this draft is focused for ad hoc extension. So my current definition is all about ad hoc EAD field. But yes, there must be a verifier, and I just haven't started to specify the verifier. And and for sure, there must be a verifier for
Okay.
for
Right.
this procedure. Yeah.
Just want to ensure that it should not be out of scope. That's my understanding. Thanks.
Okay. I will consider it.
John?
Yeah, John, I haven't read the draft yet, but I think seems very promising work. I think we need to figure out how exactly map it to RATs, and if the verifier should also use ad hoc, or if that is like out of band, and then think about the criticality. But I think this is a good start.
And Joran, it was in the queue, but has left it, I guess.
I can just say what I plan to say anyway. It's been almost been said already. Yeah, I mean, obviously the verifier needs to be in the model here, and it's very relevant what kind of evidence you're actually making use of. So there is a verifier. But I actually had another question here. You mentioned on one of the slides there's an order of preference being indicated by the initiator in the attestation proposal. And I just wondered, why does that matter? Why does the order of preference matter here? Isn't it the preferences of the relying party that is relevant?
Okay. So the order here is just to indicate that, because by default, the verifier and the relying party will just select the first, the first element in the array. But if this is not supported, I just want to say that it will select it in order. If the first one is supported, it will directly select it. It's in the case if this one is not supported, it will go to the second option, which is the second element in the array.
Right, but I see. But what I'm trying to say is that maybe it doesn't really matter what is. I mean, what matters is really what is supported by the device, because the preferences are sort of set by the relying party, depending on what property the relying party wants to verify, rather than what the device. I don't see how the device can have a preference. Maybe
Okay.
maybe not. Maybe I'm missing something here. But I think it's great that you include that, the supported types. But I don't understand the preference. We can take it offline.
Great, thanks.
Okay.
Mohammed,
Yeah, a quick question about slide 3. You were mentioning that you would be focusing on background check model from RADs, right? So can you say a bit, maybe 1 or 2 sentences about what is the motivation? What is the motivation behind selecting background check model for your application? Is it something that some use case is more let's say useful for, or something like that? Can you say a little bit about that? What's the motivation for starting with background check model rather than the passport model?
Okay. Because the current structure for me the implementation is like there will be a microcontroller, and it will act as a like the attester, like a device as the attester. And like imagine there's a gateway who can control the access to decide like whether you can join the network or not. And for me, the gateway will be the relying party. And finally, like the manufacturer of the device, which has the all of the information of this device, can be a verifier. So for me right now, the background check model is like the device is connected to the gateway, and the gateway is also connected to the like the manufacturer of the device, and it's the gateway that communicates with both the device and the manufacturer of the device. So this is like why I focus on the background check model right now.
okay, so great. So, and I guess the intent here is to develop it more again and ask for working group adoption at some point in future. Yeah.
Okay,
Great.
thank you.
Thank you.
Thank you for all the feedback.
I think next we have John.
So this is about ad hoc with PSK-based authentication, or can I say it's about rekeying or about resumption. This is in the charter and has been discussed for a quite long session in the past, but I don't have any draft yet. Next slide. But this is a time to start writing a draft. So ad hoc has been published. EMU working group has decided to adopt EAP ad hoc. And it has been, EAP ad hoc has been worked on by university, and there's company, and I don't remember which really wants to deploy that. The EAP ad hoc has requested, working on that, it has been identified that it would be good with some more, even more lightweight resumption that doesn't require so many asymmetrical operations. So when this was discussed before in Lake, the plan is to add a new method with PSK authentication, as well as a new exporter label to derive a resumption PSK. And two of the main issues is with PSK authentication typically has quite bad privacy properties, at least when you use external long-term PSK identifiers. Then you basically have something you can use to track and identify the device, which is bad. Then, of course, if you have a fixed MAC address, it might not matter, but you should probably not have that. Then PSK Key Exchange has also quite bad security properties. You don't get perfect forward secrecy. It has some other good properties also, like content resistance and so on, but you should not do just PSK Key Exchange without Diffie-Hellman all the time. Next slide. So the plan is to start writing a draft on this, and I think the need to probably differentiate between the initial handshake, and I use a TLS term because EDOC doesn't really have a good term for this. Handshake is a good, and resumption. So I think we will require ephemeral Diffie-Hellman during the initial handshake. Ephemeral Diffie-Hellman is kind of in the name for EDOC. Question is what we should require for resumption. I think resumption without Diffie-Hellman's worse properties, but it's really what matters is how often should you require ephemeral Diffie-Hellman. So I think allowing resumption with PSK would be okay as long as you have some goals for how often you need to do an initial handshake. In SSH, just as an example, this is like 1 hour, 1 gigabyte you need to do ephemeral Diffie-Hellman. Then how do we solve the privacy problems? For the resumption, it's quite easy. You drive a new resumption PSK for each resumption. Deriving a key is is very cheap, and is if you get a problem, you only send it once, and if you get a problem, you probably have to you can maybe retry on the same connection or something, but if things fail, then you do a new initial handshake. The biggest and probably hardest problem to solve is how do you get privacy in the initial handshake, assuming you have some external PSK and you have some PSK identifier. Sending this the same PSK identifier in each connection all the time is far from optimal. And some suggestion that we discussed before was should we just forbid external PSKs? You need to use asymmetric crypto for the initial, and then you only use PSK for resumption. Or do we put the requirement on whoever is providing the external PSK, so that you also have a requirement to provide a new PSK identifier each time? There's several, and then not really specify how, maybe give some recommendations. One solution that you could do if you don't have so many devices is trial decryption. So you don't send a PSK identifier at all, you just send some MAC or something, and you let the responder try all the external PSK it has. And doing decryption is much cheaper than doing asymmetric crypto, so you could try quite a lot of keys until you get to the same cost as doing an asymmetric operation. But if you have, of course, too many clients, this is a problem. And then the fourth bullet is that you require that the initiator has the Diffie-Hellman key of the responder, and then you encrypt the PSK identifier. This you can also of course do without standardizing it, but this is something you could then standardize in the protocol. And I don't really have any answers to the last questions, but this is my overview on the current discussions we had about this topic. So if you have any other ideas on anything, please speak up before we start writing a draft. Christian.
More question than an idea. So on the privacy topic, for the initial handshake, we are still talking about a situation, as is usual in ad hoc, right, where the first message is completely, say, random, and the second message is then protected against a passive attacker, but an active attacker would receive the identifying material of the responder. So how is the PSK ID privacy-wise worse than a key ID, X5T, or whatever we use in the asymmetric case?
In this case, it would identify the initiator also, which we protect. And it would be, if you have a PSK identifier in the first message, you don't get any privacy. Both the initiator and the responder doesn't get privacy against a passive attacker.
But why does the PSK ID need to be in the first message? Can it be in the second message as it is in the in ad hoc so far?
I guess it can, but then you need to change the roles. Then I typically you want the initiator maybe to initiate and also provide a PSK. Of course, you can reverse the roles, so you can also send the identifier in the third message, and then you get some more runtime. Yeah. But in general, just protecting the PSK identifier with the Diffie-Hellman encrypted in later messages would give worse privacy for the initiator. Not saying it's like something we can't do, but we should think about the properties both we want to have and what we don't want to have and what we can have. It's a bit trade-offs here.
Göran?
Yeah, on this topic of the privacy, what's your proposal? Maybe I missed that. What's the proposal that if we're using the resumption, we are deriving new identifiers, sort of so the peers can derive new pseudonyms for each resumption somehow. Was that the setting?
That was my proposal.
Okay.
Yes.
Good. Yeah. Thanks.
So it's okay. So just checking if I understand right. So it's kind of like the TLS 1.3 session ticket, single use, just one.
Yes.
Okay.
Yes.
Okay, and I guess you guys are intending to do some work on this. Are you looking for collaborators? Happy to work ahead? What?
I guess we are happy to have collaborators. I think we have quite many already.
Okay.
Yeah. But we are, at least if somebody wants to help, we are definitely very much wanting input.
Great.
Yeah.
Okay, so I guess we'll see an internet draft at some point.
At some point, yes.
Thank you. Okay, and then we move on to our if time permits. So Johan, I can pass you. So I can pass you control of the slides, Johan.
Yeah.
1 second. So you should see the slide controls appear on the bottom of your screen.
Yes.
Great.
Yes.
So great. So we have 20 minutes left of the meeting. I think Giovanni also asked for a little bit of a time. So if you can keep this to 10 to 15, that'll be great.
Yeah. So thank you very much. My name is Johann Großschädel. I'm a senior researcher at the University of Luxembourg, and I mainly work on lightweight cryptography for the IoT, but from time to time, I also look at applications of lightweight crypto systems like protocols. And this is a work that I announced briefly 2 weeks ago on the mailing list. I think it's potentially interesting for some of you guys. So it's essentially a prototype implementation of the Disco protocol. And we prototyped it on a really constrained device, which is a device with a 16-bit microcontroller that has only 10 kilobytes of RAM and 100 kilobytes of flash memory. So What is DISCO? DISCO is essentially a merger or a combination of two protocol design frameworks. So DISCO itself is not a protocol, but it is a framework for designing custom end-to-end protocols. It's a merger of noise and strobe. Noise, I think it's well known from WhatsApp and also from ad hoc. So ad hoc uses one of the noise handshakes, as far as I know. Strobe, on the other hand, is a protocol for designing secure transport protocols. So you could implement, for example, something like the record protocol of TLS, you could implement with Strobe. The basic design goal has been simplicity. So it's basically DISCO can be seen as a clean slate approach to end-to-end security. So the designers were not concerned about backwards compatibility or still supporting somewhat outdated crypto. So it's kind of a clean slate approach to end-to-end security. It's relatively minimalistic in terms of algorithm agility, and it only requires two low-level cryptographic primitives. So our prototype runs on a 16-bit MSP430 microcontroller, and we implemented two of the performance-critical components, namely Curve25519 and the pseudo permutation in assembly. So this simplicity translates into basically very simple implementation. So a minimalist version of DISCO in C consists of only 1,000 lines of code, excluding the crypto. And there are some other implementations of the DISCO protocol that are a little bit bigger, but this is still really tiny compared to OpenSSL, for example, which is a monster of an implementation with around 700,000 lines of code. How can you implement end-to-end security with only 1,000 lines of code? So the simplicity comes from both parts of DISCO. It comes on the one hand from noise and on the other hand from strobe. So noise, what DISCO took from noise is basically the handshake, so the authenticated key exchange. And I assume some of you are familiar with noise from ad hoc. So one of the design principles of noise was to avoid negotiations, which are runtime decisions, basically. So in TLS, for example, you have a lot of runtime decisions. For example, it can be negotiated what version of the protocol you use. It will be negotiated who is authenticated to whom, what crypto systems are used, and also the strength of the crypto systems. Like, for example, you can do key exchange with a 256-bit elliptic curve group, but also with larger groups. So there is a lot of runtime decisions, negotiations going on during the handshake, and that adds to the complexity of the protocol, because depending on these negotiations, you can have hundreds, if not thousands, of different execution paths. And noise basically tries to avoid runtime decisions and instead move them to design time decisions, which means it needs already be decided at design time. For example, who gets authenticated to whom, which cryptographic algorithms are used, and so on and so forth. There is still a very simple negotiation phase at the beginning of the handshake, but then after this simple negotiation phase, the whole protocol becomes a straight sequence of messages and operations. So if this is implemented in software, you do not have any branches apart from error handling. And that, of course, simplifies the implementation and also simplifies the testing of implementations of the handshake. The simplicity of DISCO in part comes also from strobe. So strobe is used to implement everything that has to do with symmetric crypto in DISCO. And The main idea of Strobe is that you use a single low-level primitive for doing all the symmetric crypto that you need in the handshake. So the symmetric crypto, not only in the handshake, but then also later on for the secure transport. And there's quite some symmetric crypto also going on during the handshake. And things that you can implement efficiently with a permutation is, for example, authenticated encryption and hashing. So SHA-3, Ketchuk is a good example of a permutation-based hash functions, but there exist also a lot of permutation-based authenticated encryption algorithms. So very quickly, some basic properties of noise. So noise is or the handshake, what is going on during the handshake of noise is essentially authenticated key exchange, but the authentication is not done through signatures, it's done through Diffie-Hellman operations. This is not something completely new. There exist previous protocols that it did in this way, like Naxos and ECMQB. MNSSQ Funstone. I suppose some of you are familiar with it. However, signatures may still be needed. Signatures in the form of certificates may still be needed for binding the static keys to identity. So the long-term keys used for authentication are Diffie-Hellman or actually elliptic curve Diffie-Hellman keys. There exist a couple of predefined handshake patterns with well-defined security properties, formally proven securities. The handshake patterns are named after the status of the long-term key. So these long-term keys for authentication can, for example, be pre-distributed, or they can also be sent during the handshake. And once a very, very simple negotiation phase at the beginning has been completed, the protocol on both the client side and the server side is basically a linear path, follows a linear path that never branches except of error handling. What is also a special property of noise is that it is possible to send early payloads. So payloads, application data basically can be appended to the messages during the handshake, and they can even be encrypted if at least one Diffie-Hellman operation has already been carried out. Of course, these early payloads have probably less security guarantees than the payloads that you send after the handshake, but for some applications it can still be useful to have these early payloads. So here is a noise NK handshake where the server is authenticated to the client, but the client is unauthenticated. And you can see here the messages that are sent back and forth, and also the Diffie-Hellman operations. Again, all these noise handshakes, there exist quite a number of noise handshakes. They have well-analyzed security properties that you can check, for example, on this website, noiseexplorer.com. I cannot go more into details here. A few notes about Strobe. So Strobe is used to do, first of all the symmetric crypto during the handshake, which means the authenticated encryption of these early payloads that can be sent together with the handshake messages. But it's also used to keep protocol transcripts on both sides, so to ensure that both sides always have the same view of the protocol. So basically, it can do hashing. Noise, the original noise protocol used two different primitives for the authenticated encryption and hashing, namely AES, GCM, and SHA-256. However, as I said before, authenticated encryption and hashing can also be done with a single low-level primitive, namely a cryptographic permutation that you operate either in sponge mode or in duplex mode, depending on whether you want to hash or perform authenticated encryption. In some sense, you can see the state of the permutation as a stateful object where the output does not only depend on the current input, but it also depends in some sense on all the preceding inputs. And of course, noise Strobe is then also used after the handshake where you then basically derive a shared symmetric key for both sides, and then do the authenticated encryption of the application messages.
So Johan, we're down to like 4 minutes. If you want to leave time for any
Yes.
questions, I suggest speed along.
Yes. So we implemented this protocol on a very constrained device. This is a typical class 1 device with 8 kilobyte of RAM and 92 kilobytes of flash memory. The starting point was an existing C implementation, but we replaced the low-level field arithmetic of curve 25519 by an assembly implementation, a highly optimized assembly implementation, and we also used the pseudo permutation instead of Ketchuk. And what we evaluated is only the computational part of the protocol. So the protocol and the cryptographic primitives, we did not implement a real prototype where messages are sent back and forth. So a few results with this noise NK handshake. The computation time of the protocol, which includes all the crypto, amounts to around 26 million cycles on both sides, which is, when the microcontroller is clocked at 8 megahertz, it's about 3 seconds. In terms of RAM footprint and code size, you can see here on both sides the RAM footprint is about 1.4 kilobytes and the code size is around 11 kilobytes. And we have also some comparison with some existing protocols like micro ad hoc or HIPDEX. And as you can see here, we are much more efficient in terms of execution time and also in terms of RAM footprint. Even though we have a much weaker microcontroller, we have a 16-bit microcontroller compared to 32-bit ARM microcontrollers. But of course, I cannot say how efficient the low-level crypto was of these other implementations. So, quick summary: we can implement a noise NK with 26 million clock cycles on a 16-bit microcontroller, and this requires only 1.4 kilobyte of RAM and around 11 kilobytes of code. Currently, we are developing a full prototype where we also send the messages back and forth. Again, what I presented is only the computational part, and we are very much interested in a post-quantum version of the Disco protocol that uses noise, PQ noise, basically. PQ noise is a post-quantum variant of the noise protocol that uses CAMs instead of Diffie-Hellman. What I presented you is also explained in more detail in a paper that you can see here, the second link. The paper about the post-quantum noise is the third link, and some more information about the Disco protocol is here at the first link. So that's it. Thank you very much.
Thanks, Johan, and thanks for finishing on time. I think we have time for a quick question. If there's anything, somebody wants to jump in the queue. John. So if we can be quick, that's good. We told that Giovanni would give him a chance at the end.
Could maybe be interesting to use ASCON, and that is standardized by NIST. I assume, if I understand correctly, using C-Shake now, or at least that's what Strobe is using. Yeah.
Yes. So Strobe initially it uses the Ketchuk permutation. Ketchuk, in terms of state size, it's not super friendly for really resource constrained devices. Also, when you think that the messages are usually short, you have a state of 1,600 bytes. So if you encrypt only a few 1,600 bits, so 200 bytes. If you encrypt only a few bytes, you still have to do the full permutation on the 1,600 bit state. So we used Xudo, Because Xsudo is quite a bit faster than AskCon. I understand that people are now interested in AskCon because it's becoming the standard, but Xsudo turned out to be quite a bit faster. And also in terms of a view to post-quantum security, with AskCon you can get at most 80 bits of post-quantum security. So in the end, when we go to a post-quantum disco, we will need a bigger permutation anyway. And therefore, I'm not really a big fan of AskCon.
Okay, so thanks. You're on. If it's okay, could you take it to the list or in the chat?
Yes.
So, thanks. Great. Thanks again, Johan. And again, he
Thank
said
you.
Johan email to the list. You know how to contact him. Giovanni, you wanted to send us some wonderful video or something?
Yes, please. What's the best way? I send you the link or I share my screen?
Share your screen.
Okay.
So we have like 6 minutes left. I hope if that's enough for you, great.
Yes, of course. My video is 3 minutes. I asked to share the screen.
Oh, do I need to give you permissions? I have to give you permission. Video published. How do I find that?
I appear in the queue just after John with the hand, but I am with the screen share.
Yes, 1 second. Grand screen. There you go.
Great.
Something is happening.
Hope you can see this.
Yep.
Great. So
cool.
I will do a voiceover because I think it will be easier for the audio. Okay, so this is a demonstration of lightweight authorization using ephemeral diffie-Hellman over COSE, which I just presented the updates a few moments ago. We are using a platform called .bot, which is a used-to-use macro robot for education and research purposes, on top of which we developed the demonstration. For the .bot, we have a gateway, which can be used to control the one or more robots, and it uses like a broadcast messaging. So we go back to the specification and we look into the diagram where we have device U. And in the case of the demo, I have two devices, device number 1 and device number 2. We also have the specification of domain authenticator, or V. So here we have a gateway, and the communication between devices and gateways is Bluetooth. In this case, we are using only the physical layer of Bluetooth. And we also need an enrollment server, or W. So we have here the .bot manager. And we have an access control list, which allows only .bot number 1 to join this domain. And we also can inspect the authorization log when the devices try to join the network. Okay, so I'll go ahead and connect to the logs of my gateway. And I will turn the first device, device 1, I will turn it on. So it sends an ad hoc message to the gateway with the EAD field, which is related to the .bot manager. And as you can see, it is authorized in the page. Just a little time so the video flows. And then the voucher is sent back as part of message 2. And the device is now authorized into the domain, and it's part of the network of my gateway. Now I'll try to do the same with device number 2. And as you can see, it has been already unauthorized. And the reason is that because it's not in the access control list. So normally, when the devices are connected to the gateway, when I press the buttons, the broadcast message would make all of them move in the same way. But since only one was authorized, when I try to send the commands, only device 1 will respond, because only one received the voucher, and therefore only device 1 joined the domain of gateway V. All our implementation, specifically the ad hoc implementation and alts implementation, is available open source. And we also have the W implementation also available online. And that's the demo. Thank you.
Great. Yeah.
Awesome.
Thanks, Giovanni, and thanks for doing it in time.
You're welcome.
Yeah, good loud clap for a demo. Maybe you can do a live demo next time if we're in the same vicinity. With that, I think we've gone through our agenda. Thanks, everyone. We'll follow up on the list as usual with everything. And now I'm on holidays. Bye-bye. I'm afraid so.
Thanks for sharing.
Bye.
Thanks. Bye-bye.
Enjoy your holiday.
Thank you all. Bye-bye.
Thank you. Bye.
Bye-bye.
And congrats, everyone, to the publication. No, I didn't.